Zoom, where this is being hosted, and also on LinkedIn and YouTube, where this is being live streamed. So if you're joining us from LinkedIn and YouTube, well, hello, good evening. My name is Ashwin. I am the head of engineering at Kickstart, and I'm going to be a host today evening, talking to all of you about part 3 of the generative AI series. So we're going to give it another couple of minutes for people to come in. So let's give it those couple of minutes, and then we can get started. So let's wait for a few more people to join. Very cool. I see that in the last minute we've literally doubled the number of people who joined. So we'll still give it a little more time so that more people can join in. For those of you who just joined on Zoom, on LinkedIn, on YouTube, once again, my name is Ashwin, head of engineering at Kickstart. Doing part 3 of the generative AI series that we've been doing. We did part 1 a couple of weeks back. We did part 2 last week, and part 3 is today. Let's give it one more minute. All right, so while all of you are waiting, let's kick off a little poll. I want to know how everyone, so what kind of exposure or how much have all of you been following this whole generative AI zoo? So let me know. I'd love to see your answers, love to see how much you've tinkered around with it. What is it that you've actually done? The poll must be up on your screen for those of you who joined from Zoom. Very interesting. And some of you build small apps with generative AI. That's very cool. A lot of you have played with ChatGPT. That's good. A lot of you just following the news. And a couple of you who mentioned that your day job is with generative AI. I'd be very interested in speaking with you. All right, and more folks are joining in, but I'm just going to wait and see the results of this poll. So if you just joined in, you might see a poll that might have popped up on your screen, which says, what have you done with generative AI so far? It gives you a few options. Would love to see what your answers are. Excellent. All right, it's 8:04 p.m. PST. I think this is a good time to start, and I can still see the answers rolling in for the poll that we put up. If you're curious, most of you have actually obviously played around with ChatGPT. Many of you follow the news. A few of you have actually built a small app using generative AI, which is very cool. And a couple of you mentioned that your day job was with generative AI, which is also quite interesting. So I think this is a good place to get started. I'm going to go ahead, share my screen, and we can get rolling from there. All right. I call it living la vida loca. It is a little bit of it is living in crazy times, right? Because there's just so much going on. Things change between upside sessions, right? So things change between 7 and 8. Things change between 8 and 9, and I'm sure things are going to change a lot more after 9. So it is living la vida loca. We're going to build a generative AI app today in the roughly 55 minutes that we have. But before that, quick introduction for those of you who came last week or attended the last two sessions. You already know this slide, but for those of you who are new here, what does my resume not tell you, right? This is my favorite interview question when I talk to candidates. What does your resume not tell me? Well, I worked at Yahoo, and the important takeaway there is I worked on NLP algorithms before the term NLP was even coined, right? So Jaccard coefficient and Jarrow-Winkler distance and all of those interesting stuff there. Wrote pieces of code to determine if two random pieces of content is talking about Shaquille O'Neal, right? So you have news articles and then you have these Yahoo Answers threads talking about the Shaq Master, right? So figuring out if those two are the same and then running it at scale, right? And causing all kinds of havoc there. So that was my life at Yahoo. Then I joined this little logistics tech startup called Yakit, where I got introduced to the term supervised learning, which is label prediction, taking a whole bunch of products and figuring out whether it was a shirt or a pant or a shoe or a sock or whatever it was, right? And doing that accurately so that we could calculate duties and taxes. Spent a lot of long nights driving up label prediction to 72%. If that's not impressive, you should be impressed. It is actually pretty good. Built the earliest ML ops model that I claim to have built. There's no verifying it, but that was my lifestyle, building that deployment model. We were doing about 2 million. We were doing label prediction for about 2 million unique products a day. So which is pretty cool when we actually did it, because ML was so new for us. Which brought me to interview Kickstart, where I built and I continue to build a powerful platform for cohort-based learning. If some of you are our students, you would have been an up level, which is built by my team. And right now, over the last many months, have been immersing myself into the generative AI world, living la vida loca, building, testing, deploying LLM-powered apps across our business stack, and today doing what I love doing, which is sharing my experiences with all of you, right? So this is who I am. Let's do a quick recap of what the agenda is. So this is a 3-part series. Part 1, this feels a little bit, doing what we do, this feels a little bit like an interview in itself. Part 1, lay of the land, where we got a sense of this entire space, right? What does this ecosystem look like, essentially? Part 2 last week was a lot of code writing, where we got introduced to Semantic Kernel, which is one of the abstraction libraries. We wrote a lot of code that felt like a coding interview round. And today is almost like a system design interview round, where we're going to build an app with using Semantic Kernel and some other stuff that I decided to throw in. So part 1 and part 2 done over the last 2 weeks. Today's part 3. But before we get into all of that building goodness, let's actually revisit, right? What have we covered so far in the last couple of sessions? Abstraction libraries, they're coming out more and more now. So we looked at semantic kernels. There's obviously LangChain, there's Haystack, there's Llama Index, and there are more coming out, right? So at the core, what these give you is the ability to abstract out a lot of the things that you need to do when building a generative AI app, right? So this is a diagram that sort of explains it well. Is what does an abstraction library give you, right? It gives you tools. It gives you the ability to connect to any model that you want to. It gives you the ability to manage text, especially because most of what these handle are LLMs or language models. It allows you to parse different kinds of output. It could be JSON, it could be YAML, it could be any of, just could be regular text, comma separated, tab separated, document loaders, ability to connect to different vector stores, and most importantly, the ability to manipulate and manage prompts, right? So it gives you all of this goodness out of the box. It just simplifies the process of developing a good generative AI app. What did Semantic Kernel do? Well, Semantic Kernel essentially was built. It is Microsoft, and they wanted to power their Copilot stack, right? This is their AI assistants that's going to be part of all of their different products or across their different product stacks. They wanted to create a clear separation between people who live at the bottom. Well, when I say bottom, at the core of the stack, right? So people who work with the foundation models, who work with the AI infrastructure, right? So they wanted to create that separation layer there, between the folks on the top here, right, or folks who work at the closer to the app layer, or folks who build apps, who build copilots, who build plugins, people who didn't want to necessarily get exposed to all of the complexities that went into the foundation models and went into the infrastructure. This orchestration layer brings about that clear separation of concern. So that is really what the semantic kernel is. And if the semantic kernel didn't exist, right? So this, I'd introduced this in the last couple of sessions that we did, a typical, a typical generative AI app architecture. You have your app, you have your input processing, you have your abstraction library, which basically connects to all of these different things, right? So you'll have you'll have a bunch of databases there. You'll have your vector DBs, relational DBs, NoSQL DBs, all of that goodness there, right? Then you're likely to connect to a bunch of different models. So it won't be just one single model. It won't be just one LLM. It won't just be ChatGPT. It could be it could be GPT. It could be Dolly. It could be some other kind of diffusion model. It could be an audio model. It could be any of these things, right? So depending on your use cases, you would connect to a whole bunch of models, and then all of the awesome stuff related to logging and telemetry, right? So the abstraction library essentially takes care of that entire ecosystem here at the bottom. And if it wasn't there, which is what the case was, let's say even a year back, you would have to write your own code, which is painful. All of us enjoy it, but we want to write new code. We don't want to reinvent the wheel in many ways, right? So you'd have to build your own custom library that does all of this stuff, right? So which is why having these abstraction libraries is actually a really, really good thing. All right, let's build the app. Let me jump out of the presentation and tell you what we are trying to do, right? So, and then we're going to jump back into the presentation and go through a few more slides. So let me jump out and show you the wonderful world of passports. Now, why did I choose this application, right? And one of the reasons, one of the use cases that a lot of people do is actually go and make things that are thrown together on websites, information which is important, right? Like public service websites like this, or the DMV or any of these sites, just make it simpler for people to consume information, because there's just a whole lot going in here, right? If you take the world of passports, how do you apply for a passport? What are the different preconditions associated with it? There are some videos here. There are some steps to apply. There are a whole bunch of FAQs there. And then there's something else for children under 16. If you've gone through this, some of you have gone through this, well, you probably understand this intimately. Then there's, if you're a 16 or 17-year-old, how do you apply for it? And then there is a passport card, and where do you get your application status? And how do you respond to, let's say, a letter for information that comes back from the passport office? There's some images here. I mean, it's quite complex, right? And then there are other nuances, like how do you get your passport fast, right? And what are the different reasons in which, or what are the different situations in which you can get your passport fast? And then how do you do things like citizenship? How do you find your citizenship evidence? How do you submit that? How do you do that for children who are under 16? I mean, it's like a whole bunch of things, right? So how do you simplify all of this and build something that can just be a simple Q&A experience, right? It can be just a place where you ask a question, it understands what you're asking, just like a real human would, who's an expert on all things passport, and just gives you an answer back, right? So that's going to be the app that we built today. And before we do that, let's sort of walk through what we're going to do, right? It's like an interview, right? So I'm going to tell you what we are going to try to do, and then we'll go ahead and do it. So go back into slideshow mode here. All right. So we are going to build a RAG app, right? RAG is Retrieval Augmented Generation. It is the simplest and the most typical kind of generative AI app that you build. Now, what is happening with this, right? What is happening with the RAG app? You take all of the information from the passport site, right? You write scrapers for it, or you do it manually, you manually copy paste it, whatever, right? You take all of that information. You do this funky thing called embedding, right? Where you convert this into like chunks of numbers that you can later query, and you dump it into a database, right? So step one, pull all the information, embed it. Step two, throw it into a vector DB. Step three is usually a user coming to your app and asking a question, right? What is the passport application process, right? And that comes into your app and then goes back into this funky thing called embedding, right? You get the embedded value back. You query your vector DB, which is like a search, right? So find me all the information related to this sentence that this person has sent me, right? So what is the passport application process? It goes into the vector DB, finds all of the relevant information back. That is step 5. Step 6 is you stuff that relevant information into a prompt, right? You give it context and say, now summarize this or answer this in a better way or whatever. That uses the LLM. And then that gives you a response back. And that is your app architecture, right? That is your system diagram is how you would actually set this up. Now, before we go into the coding part of it, let's revisit, right? If some of you have come new here or you're wondering what the heck this embedding thingy is, let's quickly revisit it, right? So what is this embedding voodoo? In its simplest form, an embedding is essentially the representation of text as a vector or an array of numbers, right? So I wrote this little 3-piece line of code, which is essentially the implementation of a Hugging Face library. So just 3 lines of code. I did this obviously with Hugging Face. When we do our demo, we'll actually do it with OpenAI. They have their own embedding service, but it takes this text, plugs it here, and comes up with this array of numbers, right? Which essentially is the representation of they call it different features of a text, but just for simplicity's sake, it's a array representation using numbers of a sentence. Now, let's say somebody asks a question, right? Does interview text something for AI? We do the same process again, right? We encode it into a set of numbers. We then run a similarity search, right? And you can do this again with different algorithms. Cosine similarity is one of the most common algorithms. Again, using 3 lines of code, something that Hugging Face gives out of the box. Takes this, runs this against all of the encodings that we've already done before, right? Of all of the sentences. And in this case, this is about 78% similar, right? So now if you have to scale this up across millions and billions of vectors, and you have to run the search across that kind of scale, you would have to do it with a vector database. And that is what vector databases are. Fundamentally, vector databases essentially bring you the ability to search for similarity at scale. And when I say similarity, it is not the world of hash tables or databases. It is the world of semantic similarity, right? It is the meaning, right? So I could ask a very different sentence, which means the same thing, right? Does Interview Kickstart have courses for AI? It would still map to the same sentence because the meaning is the same or the semantics is the same. So before we jump into code, last slide, I promise, there's a things to remember about semantic kernel, right? It takes the world of semantic generation, which is the world of prompts, which is all the stuff that we send to our different generative AI models. And then it marries the world of semantic similarity, which is essentially what state is in the generative AI world, right? I mean, in state maintenance, we do it through in-memory states, we do it through databases, we do it through caches in the world that we all come from, right? But in this new world, it is semantic similarity, which is where the vector databases come in. The third rail to that is your native functions, right? Which is essentially all the code that we are used to writing, right? The functions, the public static void mains and the def hello worlds and all of those different things that we're already used to writing. Those are the native functions. And at the intersection of that is where retrieval augmented generation lives, which is RAG, which is it marries semantic generation, semantic similarity, and native functions. And that is how it is used to actually extract information. All right, all of that talk done. Let's now get into the coding part of it. So we are going to code today. We're not going to build a UI and we're not going to do all of that fancy stuff. I am actually going to use Google Collaboratory or Google Colab. And looks like my runtime has been disconnected. So I'm going to reconnect. Awesome. So Google Colab is a place where I would seriously encourage, and I've been talking about showing all of you this in the last couple of sessions, but we didn't do that. We actually used VS Code to write all of our code. But this time I decided to use Colab because it is also a reason where I wanted to show, if you haven't used this before, fantastic tools, gives you a container where you can write all of your, write individual pieces of your code, execute it individually, have the state of that execution maintained in memory in variables. Very cool little tool that allows you to prototype things very quickly. That's what we're going to use today. It also gives you this little folder that you can play with, and which is where I've actually put this some sample files that Colab gives you out of the box. Two files I put in there. One is a .env file, which contains my secret API keys to connect to OpenAI, which is what we're using today. So we're going to be using the OpenAI's models. And the other one is this, right? Which is all of the stuff that I scraped from the passport site. So I'm not going to cover how I did that scraping and how I did that massaging and all that good stuff. But if it's not readable here, I'm actually going to open the same file in VS Code. This is what it looks like, right? So just to give you a high-level overview of what I did, I use a Python library called JustText. It gave it a URL, which is this, all of these URLs here, right? So all of this apply for a person. So I dealt with just the new passport, for the purpose of this demo, just everything over here, right? Go to these URLs, scrape all of this information, derive it, convert it into some kind of Q&A format, give it to an LLM to do that, and it came back with this thing, right? So this is all the information that we have about a passport, right? Blah blah blah. And I also made sure that I put some spaces in between this. I'll tell you why. But this just brings all of that information back, and even in this form, it actually looks pretty good, right? So if I had to just give this to someone as an FAQ, go ahead and read it. It still has enough information for you to find out what different things are. But that's not why we're here for. So that's the file that I took. I'm going to go back into Colab, and I'm going to keep it here for later. So let's get this going. So I am a Python developer. I used to be a Java developer, and a long time back used to be a .NET professional. So I've traveled a few worlds. My familiarity is with Python, so I'm going to use Python. But semantic kernel also available for C# and Java developers. So absolutely feel free to use this if you're familiar with or if you're comfortable with those two languages. But let's get going with this, right? So I'm going to go ahead and first install semantic kernel, right? So I'm essentially installing all of the packages. So in Python, the Python world, this is all done through pip. That's done. Don't worry about the second piece. This is just some stuff in Colab to help me run async functions. So, but here is where the interesting part starts. And I'm going to go to this view. And if you're there for the last session, some of this code is going to look very familiar, but just for folks who have joined new, let's go ahead and create a new kernel, right? And if all of you know what a kernel is essentially, it comes from the Unix world. It's this thing that manages all of the other things that happen, right? Which is the best explanation I can come up with it, which is processes and threading and memory and data and the hard disk, all of those things. So, but in its central form, when you start a kernel, it is empty, right? And once it's empty, you need to attach some services to it. So in this case, we are going to attach two services, right? One is a text completion service, which is used to essentially generate text. And the other one is the embedding service, right? So the embedding service is what calculates your embeddings, all those vector of numbers, and then we figure out what to do with it later, right? So this is the embedding service. So the text generation service, we're going to use GPT 3.5. OpenAI has its own embedding service, which has its own model called text embedding ADA. Let's go ahead and attach this. All right, so now that is done, let's get to the interesting part now. We want to now load that passport text file, right? All of that stuff that we had there. We want to load it into a vector DB. Why do we want to do that? Because we want to be able to get context of stuff that we actually search for. So let's go ahead and write a couple of functions that actually does that, right? So I created this little class called memory skills. And I'm going to walk you through code. I'm not writing code because I just want to make sure that we finish this on time. And I also hope that this size is good enough for all of you to follow. If not, let me just increase the size a little bit. There you go. So what we are doing with the memory skills class is we define two functions. One is load the memory with the embeddings, and the other one is search the memory, right? Search it for some text. Now you'll see these little decorators. I won't go into the details because you should look up semantic kernel, but anytime, for the short form or the TLDR version is anytime you want a function to be treated as a skill by the kernel, as a plugin by the kernel, you need to annotate those functions with these things, right? You need to give it a description. You need to describe clearly what the function does and what the different input parameters are, right? So the reason it does that is because of a thing called planning, which we are not covering today, but we covered in the last session, where this tells the kernel that this is a function that I can work with and I can use whenever I need to use it, right? So that's what these decorators do. But let's get into what's happening inside this in memory vector DB. So what's happening is we are getting the text from that file, and the code to actually do that comes a little bit later, but we're getting text from that file, we're splitting it by those blank spaces, right? So we are essentially treating each FAQ as a single unit, right? So we are splitting this by these four things, and there is no set pattern to this. The point I wanted to make is I decided to do it this way because it worked best for my use case, right? And there are other chunking strategies, right? People chunk by sentences, so it'll actually chunk by different sentences, and there are out-of-the-box libraries for that. You can chunk it by tokens. So a token is essentially 3/4 of a word, or roughly 4 characters, right? So you can chunk it by tokens because LLMs essentially work in the token world, right? They charge you by tokens. They can restrict themselves by tokens. But I decided to do it this way. The reason is when I want to give answers, I want to give self-contained answers, right? I don't want to do half of this answer and half of some other answer. The way this file is set up is that this entire thing forms one self-contained answer, right? That I want to give people. So which is why I generated it in this format. And I put these little separators here that allows us to chunk it by each individual question. And then I go ahead and save that information, right? So I calculate the embeddings. This one line does everything, right? It basically goes to OpenAI, sends that piece of text, there's this one whole question that you see here, question and answer that you see here, calculates the embedding, sends it to OpenAI, calculates embeddings, brings it back, and stores those embeddings into the memory, right? So that is what this load in memory vector DB does. And search does the exact other side of it, right? Which is, given this, let me go ahead and search for this particular text and find out similarity. So let me go here and let's import. Now that you've created this, let's attach it to the kernel, right? So these skills, let's attach it to the kernel. I didn't run this code. So let me go ahead and run that. And let's rerun this. And there you go. So now that this is attached to the kernel, it recognizes the two functions. How did it recognize it? Using these decorators, right? It's like, oh, I find these two functions. I can work with these two functions. They're called load in memory vector DB and search in memory vector DB. Awesome. So now that it's done, let's create a function to read our data and actually load it into memory, right? So I created this little function, and I'll go a little fast because some of these are less important to this demo. So I'm going to read this file. You can do it any which way. Let's just text, print this. Yep, it's read all of the text. And you'll see these little things. Now, kernels work with context, right? So when you want to fetch data from one thing and send it to another thing, the kernel maintains, just like the kernel in Unix maintains a thread memory and a process memory where it uses to actually move data between different processes and threads. A kernel uses something called context, right? And this context is like this global thing that contains data that the kernel can use to shepherd around to different parts of what is attached to the kernel. We're going to create a new context. And now we are going to load this memory. So what are we doing? We're taking that text that we read from that file. We are creating a new collection or a new table inside this in-memory vector DB called passport stuff. And we are going to load it. Now, this is going to take a little bit of time because it is calculating the embeddings. I'm going to actually run it, calculating the embeddings, sending it to OpenAI, calculating embeddings, bring it back, and loading it into memory, right? So let's go ahead and wait for this to complete. All right, took about 11 seconds, took all of that text, generated the embeddings, put it into the vector database, right? Now let's test it out, right? Let's test it out to see what happens. So I created this little function to search that memory, and let's go ahead and see what comes out of it, right? So enter your query. What is the passport application process? So I'm asking it a question. Let's do that. Very cool. So this has actually gone into memory and it has returned all of the relevant results. So there are three relevant results here, which is what is the process to apply if you're 16 or 17, if you're below the age of 16, if you're over the age of 17. This is fantastic. Why did it return only three results? If you go back to this, I am explicitly telling it to return only three results there, right? And you can again play around with this by yourself. You can make it 5, you can make it 10. Obviously, if you give too little, then you might not get the right result. If you give too much, then you might get a lot of noise. If any of you is from the world of machine learning, you would recognize precision and recall. I mean, this is a place where if you understand that, there's a good place to come and bring this in. I got this by trial and error, by different testing methods. I figured out that 3 is the right number for me. You need to play around with what your number is when you actually build something like this, right? So, all right. So we came here. We are right here, right? So we have a vector DB. We loaded it up. Just if I take you back to the presentation very quickly, right? And to the slide that we had. What have we done so far? We've done step 1. We've pulled all the data. We've done this voodoo magic with OpenAI, which is calculate all the embeddings. And we've done this step 2, which is we went in and pushed all of that data into a vector DB. We did step 3, where we sent in a query. What is the password application process? We did step 4, which is again calculate embedding for it. And we did step 5, which is actually searching. So pretty cool, right? In about 20 minutes, we built 5 steps of a generative AI app, right? Awesome. Now let's get back to building the rest of the story. So let me just go ahead and clear that. Now let's bring in the semantic functions part of it, right? So we've done the semantic similarity part, where we loaded up the vector DB. We did the native functions part, where we built all these functions to search the memory and load the memory. And let's get the semantic functions part, right? And this is the third part of retrieval augmented generation, right? So this is a prompt that we wrote. You're a helpful customer service agent, blah, 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 who answers questions about the US passport. This seems like a very nuanced query, right, in first thought. But know that even the process of building prompts is a step-by-step process, right? It's an iterative process. I came to literally about 5 or 6 different iterations before I landed on this prompt that gave me the kind of results I want. So while it might seem that this is a prompt which is very nuanced and requires a lot of knowledge to be able to write it, it doesn't exist, right? The semantic world is all about figuring out what the right thing, figuring out the chemistry, so to speak, right? Is what is the right kind of things you need to tell an LLM to be able to have it generate exactly or the kind of responses that you want, right? So this is the prompt for me that worked. You will have to discover your own prompts for the use cases that you drive. Let's go ahead and create, and we're going to create a semantic function called get password info, right? So I'm going to go ahead and execute that, and that's done, right? And I'm going to create a native function to execute that. Now let's try this, right? So I'm going to remove that, going to remove some of these things. All right, what is the passport application process, right? So it's going to search the memory first. So we sent it to search the memory. Then it goes ahead and then runs that semantic function. So it sends all of that context, all of those search results that we got from the memory, stuffs it into the semantic function, which is running this prompt, where we stuffed all of that context from the memory over here. We sent it the user query here. It came back with an output. Let's see what that output looks like, right? Not bad, right? It took all of that, it summarized all of that information, sent it back, right? So this is much better than having to go here and poking around all of these different places, right? Suddenly this becomes very, very simple. Let's try a different question, right? So let's go in and say, how much does it cost, right? So it goes into memory, gets it done. Let's see what comes out of it. The cost of the application, if your age is below 16, is passport book 100, passport card 30, passport book and card 160. Now, the thing here is that even though this answer is relevant, it still doesn't have context about who you are, right? So, which is why some of these different statements come in. You could easily then do more things to actually make this more relevant, and which is what we are actually going to get into. But in its most basic form, going all the way through this process, we have actually built a generative AI app. So if you go back to the presentation, we got until step 5, remember? Now that we have all those results, we did step 6, which is send it to the prompt. Then step 7 happened where we sent it to the LLM, right? We sent it to ChatGPT using GPT 3.5. And then the LLM sent back the answer to us, and we returned that back to the user, right? So we went through this entire process, right? We went through 1, 2, 3, 4, 5, 6, 7, 8, all through. And that is your most basic generative AI app, or the RAG example that you can build here, right? So imagine that. We took an LLM model in the space of about 30 minutes. We took an LLM model, we took all of that stuff, stuffed it into vector databases. We figured out, we ran a search through it, got relevant results back, took it and sent it to an LLM, summarized it, and sent the answer back to the user, right? That is how easy it is to do this, right? So that is how easy it is to enable this entire process, right? So just going back into the presentation very quickly, let's review, and then let's get to the second part of the coding, right? So let's review what we've learned so far. Attach generation and embedding services to the kernel, right? So we did this last week, we did this again, choosing, and I put this here because you need to choose which model, you need to choose which embedding service. You can use Hugging Face, you can use OpenAI, you can use other, Llama has its own one, I'm sure Bard has its own one, so choose your embedding service, right? We chunked up and loaded the file into a vector DB. We searched the DB for answers to our query, so we got a list of relevant answers. We got the LLM to summarize our answer for us, and we built our generative AI app, right? So that's the most basic app. Obviously, you can put more fancy stuff on top of this. You can put like a UI, you can put an API, build like really nice experience for the user to actually go through this. But in its current form, pretty good. But let's go a step further, right? Let's try to make it more interesting. Now, if you look at the passport side, right, there is a lot of nuance here based on who you are, right? So if we know more about the user, if we have more information about the profile, right? So for example, we have people who are 16 or 17-year-olds who have a specific application process. Or if you're under 16, you have a specific application process. Or if you're over 16, you have a specific, or over 17, you have a specific application process. And then you have all of these interesting things, like, you have helpful stuff, right? So you have a video that helps you understand. So if you don't want to read text, you have videos, right? So you should be able to access videos in that response, right? So you have videos. Let's say you have you go to photos, and then you have all of this interesting stuff here, right? So it gives you passport photo tips, and then there's an additional video saying how to make sure this one, right? How you do the right video. So you have a lot of this nuance there, which goes missing in the LLM world, right? So how do you get a little bit more context about the user? So how do you marry more context about the user? And then how do you figure out what additional information you can pull out related to what the user wants, right? All of that sounds very vague, but let's sort of break it down. If I go back into semantic into Google Colab, I put this whole thing called "Let's Make It Interesting," and I kid you not, I was literally working on this until about 15 minutes before the presentation. So if anything breaks, we'll have to debug it together. So let's make it interesting. So when I say let's make it interesting, I actually really mean it. So the first thing I decided was, let's find the intent of the user's query, right? Because you come to a site like the US passport site having an intent, right? So what is that intent, so that then I can do a lot more interesting things with you? So I wrote this query, again, decided to write a semantic function, went back to the LLM and said, let's ask an interesting question here, right? So depending on the query that you're asking me, classify it into one of these intents. And these are all the things you can do associated with a new passport. And I'm again focusing only on the new passport. You have a whole world associated with renewing passport, citizenship cards, immigration visas, and it's like a whole other business there, right? But specific to first-time passport applications, this is the world of it, right? These are the different intents people could have. And in this process, I'm using something called end-shot learning, right? You should look it up. We covered it in the first in our first session a couple of weeks back. Is end-shot learning. I'm giving it a few examples of how to detect intent, right? So I'm doing that, and I'm telling it, please make sure that you map the intent, whatever the user query is, to this, right? So, and I created a semantic function out of it, and I tell you why I did that. But I want to be able to do interesting things once I know the intent of the user. So I'm going to test this. Let's do. What is the passport application process, right? All right, sorry, I need to run this first. Then I need to do this. Right? So let's go ahead and do that. All right, let's do the same query again. What is the passport application process? It says good. So it gets, this is the new passport application. Let's try another one. Let's try something which is not direct. What kind of pic do I need, right? Nice. So it says passport photo requirements. Let's do something really out there. Right? I need to travel to Portugal urgently. Great, emergency situation. So it's doing a pretty good job of handling intent. And again, just reiterating, I didn't write this prompt right off the bat. It took me multiple iterations, in fact, pretty late into last night to figure out what is the right prompt to do, right? So, all right, so now that we have our intent, let's handle this intent, right? How do we handle this intent? So I decided to do a couple of things, right? One is, given that we need to know things about the user before we give them the right answer, let's ask those things of the user, right? So I created this native function called ask qualifying questions. And again, apologize for the code over here, but I had to do this fast for this demo, so it looks a little messy. But I'm actually asking a bunch of questions, right? What is your age? Do you have a passport, right? If you have a passport, was it lost, stolen, or damaged, and blah, blah, blah. And this is coming directly out of all the stuff that is here, right? So all this, so these are the pre-qualifying questions that I'm actually asking a person. And then I'm deciding whether, you need the steps for if you're over 17, or if you're under 16, or if you're a 16 or 17-year-old, right? So that's how I'm making those decisions here. So these are all the qualifying questions for that, right? And secondly, for another use case, I'm asking citizenship questions, right? So what kind of IDs would you need? So were you born in the US? Or if you were not born in the US, were one of your parents born in the US? And if they were not born in the US, do they have a green card? And so on and so forth, right? So how do you decide who can apply or what kind of citizenship evidence you need, right? So I'm going to go ahead and create this question skills class, which has these two functions, right? Ask qualifying questions and the citizenship question, right? So I created that. Now I'm going to create like a little router, right? So now that I know the intent, I'm going to now do different things with that intent. And for that, I created this class called router skills, which has this function called route query, which takes in the passport intent, right? So once I get the intent from the semantic function, I pass it through the context, get the intent, and then do interesting things with it, right? So by default, I need to search the memory, the vector database, get information from there. I need to craft an answer, right, related to that. But before I do all of that, I'm going to give it some more context, right? So this is where I'm going to ask my qualifying questions. So I created that file here, remember? So I'm going to ask qualifying questions. And now I'm going to send those qualifying questions to the prompt, right? Saying, this is the user query. Oh, by the way, this user is asking a bunch of other stuff. And I've put these few print statements in there as I run this so that you can actually follow along, right? So we do all of that. We run this. We sort of get the answer back from the LLM, and then we can do more interesting things, right? Because we have more context. Obviously this is a little hard coded, but imagine you could easily stuff this into a database and get more specific information related to the context of the user, right? So, and we did this for different things, right? Passport applications, forms, citizenship evidence, all of these things are different use cases, right? So obviously I haven't tested all of this. There was one bug I was still trying to fix with this, but let's go ahead and still run, right? Let's run this and see. So I've created this class. Let's go down and let's import these bad boys, right? So like any skill or any function that you create that needs to be used by the kernel, you need to import it, right? So it's gone ahead and imported all of that. I'm going to go ahead and close that. Let's create a function for running this router. No, I'm going to actually ask a simple question, right? What is the passport application process? Right. And here, I'm going to send in that input. I'm resetting all of those different context variables, right? Because I don't want to reuse this across different queries. You can obviously, the reason why we have it in context is so that over the course of a conversation, you can retain context of the user. But just for the purposes of this, I'm actually going to reset all of this and call that router. Now, what that router is doing, you'll see. So I'm going to actually run this. So it says, before I answer that, let me ask you a few questions first. So what does the applicant's age? I'm going to say 14. Does the applicant currently have a passport? No. Has the applicant already applied for a passport? No. So now it is now created this context, right? So we'll wait for that answer to come in. But first, let's go through this. These are little log statements that I put in just so that you can follow along. So what did we do here? We asked qualifying questions, right? Your age is 14. The applicant does not have a passport. So the applicant is eligible to apply for a new passport. So we are establishing eligibility there. If you didn't have eligibility, you could go a different route. What is the passport application process? This is now the query that is going to the LLM. It is not just this. So in our original example, we were only sending that. Now we are sending more context to the LLM, right? So what is the passport application process? The applicant is 14 years old. The applicant currently does not have a passport. The applicant's intent is new passport application, right? So we've now given it a lot more qualifying information to the LLM. And now look at what the LLM is doing, right? It is giving you information specific to your use case. It is saying you need documentation of parental relationship because you're 14 years old. You need to show parental consent on the passport application because you're 14 years old, right? And this is a video of the application process specific for children, right? And then you have these links to the forms, right, which you can click and you can directly get started on those forms, right? So you have all of this additional richness built into this process, right? And obviously, if you are a great front-end engineer or a great UI engineer, you can make this look a lot nicer. If you're interested, the bug I'm trying to fix is this additional stuff that comes in below, which basically dumps the kernel state onto the terminal. So I'm trying to figure out how to get rid of that. But for the purposes of what we're doing, everything over here is what it does. So let's do a different example, right? So I'm going to ask the same thing and let me ask it. And again, I don't know what the output of this is because this is a probabilistic world. We could come up with a completely random output when we do this again, right? So let me try that. So resetting all of the context, we are running this again. And it seems to be taking a little time. All right. This is what is known as demo moments when you're in the flow and then suddenly your demo refuses to cooperate with you. So let me try that again. All right, let's go. All right. So I'm going to say I'm 40 years old. I have a passport, but it was lost, stolen, or damaged. Now, I haven't handled the case where what do you do when you're lost, stolen, when it is lost, stolen, and damaged, because you need to file another set of forms there. We can easily add that in, as a additional thing. Has the applicant already applied for a new passport? No. All right. What happens here? it says all of that stuff is relevant, but then it shows you the application process for an adult, right? Now it has become very contextual because we gave it all of that context. It knows which answer from the memory to pick, how to craft that answer, and get more relevant info associated with it, right? So that's sort of how you can enhance this and how you can make this more interesting. How are we doing on time? We're doing fantastic. So I'm actually going to pause here and go back to the presentation and cover the last few slides, and then I'm going to take questions because I'm sure all of you have tons of questions. I can see the Q&A tab on Zoom buzzing. Let me go back to the presentation here. All right, let's code up part 2. Go back into slideshow mode. So what have we learned so far? LLMs are awesome. They are. But they do need some tinkering around to get things right? So you need to sort of build, especially when you're building semantic functions, you need to sort of build your prompts and build your set of instructions that you're giving the LLM to make sure that it actually gets things the way you want it to. It is still probabilistic. There is still, a level of unknown when it comes to expecting what is coming back from the LLM, but there are ways of controlling it, and that's where you need to do that tinkering around. I mentioned this last week, vector databases are your friends, right? You need the way to get the LLM or the way to get any generative AI model to sort of narrow its focus is to give it what I in school used to call an open textbook exam, right? Here is a textbook. Here is a find your answer from this textbook. You sort of plug vector databases into the RAG world. Use native functions wisely, right? They make your life really, really easy. The more deterministic pieces, so native functions are essentially the deterministic parts, right? It's the syntactic word. The more native functions you can add into your process, you can just control the probabilistic nature of all your semantic functions, right? So you can give it more context. Like, for example, we asked more qualifying questions, right? The reason we did that is we wanted to make the answers more contextual, right? So use native functions wisely. Like I said, play around with prompts. It's the new world of coding, and I'm not kidding you, right? So playing around with prompts is important. Crafting of prompts is important. This is basically just like you write code to tell your compiler or to tell your runtime environment what to do. Prompts is telling the LLM what to do, right? So as important as writing good code and writing the right code is critical, writing the right kind of prompts is also very important, right? So it's the new world of coding. So play around with prompts. And covered in future sessions, we didn't cover a few things here, right? Which is important in sort of a Q&A context. The most important piece is the conversational memory, right? So if you've used ChatGPT, you know that, as you have a conversation, you can ask a bunch of questions and it seems to remember what you've asked before, right? For example, I could be asking, what is the process for a new passport application? It gives me an answer. Then I say, okay, how do I get started? It should know that I'm talking about the passport application process, right? So that is conversational memory. There are 3 ways to do it. You maintain the entire Q&A history that you have, and you keep stuffing it into the prompt saying, hey, this is the conversation that has been had so far. But, over a period of time, that can get really large if you're having large conversations. Another way to do it is generate summaries. So again, you use the LLM, send all of the previous context, send it to the LLM and say, give me a summary of this conversation, and I'm going to add that as context, right? Or the third thing where vector databases are your friends is you stuff that conversation history into a vector database, right? So in the space of a conversation, you could be talking about shoes, and then suddenly you could be talking about football, and then you want to go back to shoes. The vector database will only pull out the pieces of the conversation that are relevant to shoes, right? And that is an important piece of how you have a proper conversation with a user, right? So conversational memory is its own topic, is its own beast. So we're going to cover that in future upside sessions. How do you use planners, right? What are the use cases for using planners in generative AI apps, right? So I covered planners last week. So planners automatically create what functions or create the sequence of functions that you need to execute given a text ask, right? So in this world, the use case that I would have loved to solve is, hey, I lost my passport. I need to apply for a new one, but my 12-year-old kid also needs a passport. and I'm traveling to Portugal in 2 weeks. What do I do? Right. And this thing then goes in and figures out exactly what are the sequence of events. If I was a real life passport agent charging money for this, I would say, okay, let's figure out your passport situation first. Then based on your passport situation, let's figure out your child's passport situation. And the reason to get it fast is because of this. So there are these additional forms you need to fill. That is what a planner does, right? And that is a use case I would have loved to show you, but we will get there. I mean, we will actually look at planners in a future session in the context of a generative AI app. How do we reduce hallucination? So one of the things we didn't see in this demo is that this demo still hallucinates, right? So there are certain use cases. For example, I asked a question about who wrote Harry Potter, right? And it should have come back and told me, well, that's got nothing to do with the US passport process, but it actually tries to go and answer it from the database, right? So there's a process we have to figure out how to reduce hallucinations. That's its own topic. So we're going to cover that in a future session. Fine tuning is its own beast. Definitely it needs a session, logging and telemetry. And obviously we need to talk about Hugging Face, which is the model hub for everything, right? All right. I think we are just about at time. Before we go, you can do the same passport example, right? Do it yourself. Try building this app yourself, right? Try using semantic kernel, build it yourself. But a few other ideas that you can do, again, I talked about some of this last week. Take in customer reviews, classify sentiment, email a summary to you, right? So it marries the semantic, the syntactic word, but it doesn't quite quite do the vector similarity. So that is one app without the semantic similarity piece. The second one has all three, right? You create an app, read some Wikipedia articles, stuff it into a vector database, and then answer questions on it, right? So very similar to the use case that we are doing. Third can be something you do at work, right? You create an app that connects to your Slack or Discord channel, get messages for the last week and generate a list of action items, right? So what is it that you missed? You went on vacation for a week, right? So you want to come back. What did you miss? And what are the things you need to do, right? If you had an app that told you that, that'd be very cool. So some thoughts for all of you to play with. And let's do Q&A. So I'm actually going to stop sharing. I'm actually going to look at the Q&A and just read the questions for a minute and get a sip of water. Very cool. So can you please share this collab notebook? Yes, we can do that. I can share this collab notebook. I'm going to take away my secret API key and things like that. So whatever is secret, but I'll share this collab notebook. And there are a few other people who asked the same thing. Somebody asked, can you add ranking and relevance to the results that are returned? Absolutely. So if you were there last week, let me actually go ahead and share my screen again, right? So this might be helpful. So let's see, I'll go back here. I did this last week, right? So in the same use case, and let's see if I can actually search. In the same use case, in the code that I wrote, right? So let me go back to, sorry. Let me go back there, go around this. So let me go to the semantic function that I created, right? So in this case, I only care about the results, right? So I'm only caring about the text that comes out of it. So this is actually a Python dictionary, or it's like a map, right? It has the text, it has a relevance score. So in this example that I showed last week, I just want to show what the text and the relevance is. It actually has a relevance score. And it actually, when it returns it sorted descending, right? So in this case, you get the top three results. So when you do this, in this case, I've done limit 2. In the example that I showed you, there's limit 3. It sends the top 3 results sorted by relevance score. And one of the things that you can also do when you're actually searching your vector database is add something called a min relevance score, right? So min relevance score, and you can set it to a number routine 0 and 1, which again controls these two concepts of precision and recall, right? So you can set a really low relevance score, which is something like 0.1, which is like, get me as many results as you want, or you could set it really high, right? You could set it at 0.9, saying, I want only high precision or high or results that match very, which are very close, right? So you can actually control it that way. The default, if you don't give anything, is actually 0.7, which is actually a pretty good one, right? So which is a pretty good score, especially in the context of getting a bunch of things. So the answer to your question, just wanted to show you that, yes, you can you can actually add ranking and relevance to the results that return. All right. Other questions? Can you share some tools for web scraping and any data cleansing requirements before vectorizing it? Yes, actually, you know what? We should do a session for that specifically, because that's its own whole world. I mean, I use something called JustText, JUSTEXT. You can look it up. There's this whole world, right? There are a whole bunch of tools that does this. Absolutely, you can use any tool that you want for web scraping. But the more important thing to talk about, and why an upside session would be very cool for it, is how do you structure the data, right? In my case, you saw that I had this text file separated by 4 new line characters, and I was able to split it. And what are different chunking techniques, and why would you use them, and for what use cases, right? That is really the question that needs answering. So more than the tools for web scraping, let's do a session specifically on what are different chunking strategies, and why would you use it in different use cases. All right, in step 7 in the drawing, are you sending vectors to the LLM, which is my cue to share my screen again. Let me go back there and share my screen. All right, the answer is no. We are not sending vectors to the LLM, right? So we are keeping the vectors in the vector DB to enable, sort of easier matching. But prompts are the world of text, right? So or LLMs are the world of text. So we are actually sending the text. So if you go back to this collab notebook, let me tell you what we are actually, well, you can't see it here, but we are only sending text to, go down there, let's see how it all fits in together. So we are sending text, right? In this prompt, we are sending text, and the context that we are sending is actually text, right? So, so in all of this, in step 7 that we do here, all of this is actually text, because we send text. It's an instruction. It's part of the prompt that goes to the LLM, and the LLM sends back text, right? So the process of actually getting stuff from the vector DB, when you remember when I showed you that search result where we had those 3 results, that is actually text coming back, right? Those relevant results are text. It is so using the vectors to do a similarity match, but then it's decoding that and getting the text back. So the short answer, yes. Short answer is no. We're not sending vectors to the LLM. We're actually sending the real text. Great question. What is the rule of thumb for embedding selections, size, domain, cost, latency? And like I said, that requires its own upside session. But here are some things that you can think about, right? 1, which LLM are you using, right? In my case, it is GPT 3.5 Turbo 0301, which specifically has a context length of 8,000 tokens. And that context length involves my input prompt, which includes all of the context and all the instructions that I give, and the output answer, right? So generally, if I want the context size to be limited, or I want the input context size to be limited, then I'm going to make sure that my embeddings or the stuff that I'm actually sending to the prompt is not very large in size, because my prompt is already large. If my prompt looks like this, right? So let's look at that semantic function again. So my prompt looks like this. This is a lot of instructions, right? So this is a lot, and there are token counters that come in as part of semantic kernel, or there are open source. There are libraries like tick token, interesting name, but these actually allow you to count tokens of any kind of text, right? So you can take this prompt, when you stuff in all of that context, and you've seen the size of the answers that we had, and then you have an input, and I know that my input is generally going to be like a single line, so this is not going to take up a lot of tokens. This is a fixed size of tokens. This is something that is really the variable there, right? The relevant result. So with that, I try to figure out what is the largest token size I can fit in here, so that I don't cross that 8,192 tokens, or get close to the 8,192 tokens, right? Because the more number of tokens, the more is your cost, the slower are the LLMs in some cases when they have to go through a lot of instructions and generate a long answer, and which is our case, right? We give it a lot of instructions, and then it generates a long answer based on those instructions. So I would typically, it's not a very clear answer, but it is some directions for you to look at, right? So Domain doesn't have to do anything with it as much. Cost definitely has to do with it. The size of the prompts that you send definitely has to do with it, because that directly impacts latency. And basically, it also depends on the kind of use case that you're solving, right? And I think that is worth mentioning. If you want to give the kind of answers that I'm giving, which is more long and detailed and maybe stepwise instructions, you do want some leeway to leave on the token side, right? For your answers, you want to make sure that your prompts are more tighter. But if you have generally single word or single sentence or small paragraph answers, then you have a little more leeway on the token size on your prompts, right? So that is how you can start thinking about it. Is do I give more instructions to get a more specific answer, or do I give lesser instructions and let the LLM go wild, right? With its generation task. So those are really things that you determine. But again, something that needs its own upside session, because there's a lot to talk about there. We have 5 minutes over, but I'm going to take a few more questions. Sumajit Sharkar, you've asked which part of the process is randomized. So I'm assuming you mean outside of the LLM world. What is randomized? So native functions are deterministic because they do exactly what you do ask it to do in code. The vectors are deterministic. So if I take the same sentence and run the same vector or the same encoding algorithm on it, I'm going to get the same vector, right? There is no randomness there. I'm going to get the exact same vector because that's how you do similarity, right? So that is deterministic. The similarity algorithm is deterministic, that is cosine similarity. The only process which is probabilistic are the semantic functions, right? Are the world of LLM, which is why we have such long prompts that actually go into it, right? So it's not, I wouldn't call it randomized, but I use this example in my first session. Is it's like telling a child to draw a picture of a dog, right? Or draw a drawing of a dog, right? And you don't know what's going to come out of it. The child is going to access its own model of dogs that he or she has seen in their lives, and try to create a picture of what forms a dog and actually produce it on a piece of paper, right? That is the generative AI process. So it's not random. I think it is probabilistic. I think that's the right word for it, right? So it is probabilistic. It is something which you can't predict what is going to come out of it. But if the quality of the LLM is good, or the child's memory is good, or the child's ability to articulate is good, or to produce drawings is good, then you know that the output is going to be good quality, right? So that is really if you have to call it, the random process in this whole ecosystem. Pavitra, please suggest some books or references for prompt engineering. Well, I'm going to try very hard not to plug Interview Kickstart in here, but yeah, I mean, if you go online and look, you're going to find a whole bunch of courses. You have deep learning, you have Coursera, you have Udemy, obviously tons of stuff on YouTube. I'm not sure if there are books out for prompt engineering. I'm sure given the speed at which this moves, there must already be there. But yes, you can actually go online and look for. There are tons of free resources. You're going to find a lot of good people who want to teach you. But I'm going to try and get someone from our team to actually send you that list. So thank you. That's a good question. It's a good follow-up thing that you need to do post these sessions. So Apurva Mathur says, is there a way to get the LLMs to share the level of confidence in an answer? I suppose a similarity matching in VectorDB can be, does the same thing, but not sure if it can be done using the LLMs directly. The answer is yes. So when I was crafting my intent function, right? Let's now attempt to find the intent. Do you see this? It is actually giving me the confidence score in its mapping, right? So this prompt itself is, please return the highest confidence intent from the following list. And, I had all of these intents, and I tell it exactly what I'm going to do with it. So make sure that it's just one intent. I'm saying do not include any explanation of your mapping or the confidence score, right? So the answer to your question is yes. in this case, I didn't want the confidence score back in the response, but I'm telling the LLM to evaluate a confidence score by itself so that it can actually choose the best intent from this list. So the answer is yes, you can get the LLM to do that. But again, I think you do that in very specific use cases, right? In this case, I had a very tightly controlled prompt with the fundamental assumption. So when I'm an app developer, when I'm building this app, the fundamental assumption is that people are going to ask me specific questions, right? They're not going to ask me what is the meaning of life, or who wrote Harry Potter, or who is the current president of Uganda. I don't know, right? So they are going to be very specific questions related to passport, and I can always figure out, I can weed out the 1% use case of non-relevant stuff and generally keep it to within this. So which is why I'm saying these are all the intents, right? I care about these to make sure that you have a relevant score. Even within these, have a relevant score so that I can send them to the right. So the relevant score is a good place to. Is a good way to control prompts. Pavitra, you have a follow-up question where you say the relevant score should be sufficient to control hallucinations of the model. The answer is depends, right? So one of the things with models, and they're getting better. OpenAI is working on it. Bard is working on it. Obviously, the Meta team is working on the Llama models. We have Mistral, and we have other independent people who are solving this whole hallucinations problem, right? Because one of the things with LLMs is that they're exceptionally good at following instructions. They're like kids, right? So they will follow instructions up to a point, and sometimes there's just some completely ignore your instructions, right? So, and it's very hard to tell when that will happen, right? It's very hard to predict when that will happen. So, which is why, all of this context stuffing and all of this stuff that we mentioned in the prompts. I mean, imagine giving the kind of instructions you're giving here to your kid, right? I mean, your kid might zone out about halfway through this, but essentially you're trying to give all of this context, and you're trying to say use only this, and make sure that you return only this, right? So all of those are things that you do to reduce hallucinations. I think there still needs to be more work done on the LLM side, that is on the foundational model side, to completely eliminate it, right? So and I think there's a lot related to the word generative itself is the key, right? It is generating stuff, and its spike or its want is to generate stuff. So if it cannot find enough information, it's going to look someplace else to try and generate stuff, right? So controlling that is going to be one of the key areas of the improvement in LLMs that we see over the year. But while we are waiting for those to happen, as a generative AI app developer, I'm going to do the best I can with the tools I have, which is using vector databases and which is using prompts there, right? So there are questions still rolling in. In the interest of time, I'm going to take a couple of more questions. Ashish, you're asking, will you be covering about adding front end to this app and deploying it? Well, I'm going to cover deploying. Front end, well, there are enough and more things on how to use React, how to use Vue, or how to use any other framework, Angular. But what I will cover in a future session is what does it mean to build generative AI? What does it mean for user experience for a generative AI app, right? What is the right user experience for it? And even though I don't claim to be an expert, I'm starting to get better ideas around it. So I will cover that part of it. I'm not going to cover how to code in React or how to code in Angular. I think there are enough and more resources related to that. And Jayanand, I think you're asking, is the recording and the session available? Absolutely. So this is going out on LinkedIn Live. This is going out on YouTube. You'll find the recordings there. So absolutely, you can review the session. All right. I think we have a few more questions, but I think both I've answered those. We are already 14 minutes over. I'm actually going to stop sharing. I really appreciate this. This has been a lot of fun for me. So this is 3 sessions that I've done, and it's been an incredible amount of fun getting through those and sort of unwrapping and unpacking sort of this world of generative AI. We're going to get into more detailed stuff in future sessions. So look out for those emails and look out for those topics. Thank you all so much for being with me today. Thank you all if you are attending for the 3rd time. Thank you all so much for attending, coming back and attending the series. I hope you all go back and tinker with this, play with this, build better generative AI apps, understand this, understand this ecosystem a lot deeper. And until the next session, I give you all power. Live in la vida loca. That's the motto as you live in this world. So have a good evening, and I look forward to seeing you all in future sessions. A little poll has popped up here about the session. Please let me know how we could do it better. What are the information you'd like to know, and we'll make sure that this session really is worth your while. So have a good evening, everyone, and thank you very much.